So in your JAMB, you probably know how to solve motion problem, but one thing you're not familiar with is that in post UTME, they tend to raise the bar a little bit higher. So this is what they do. They give you some questions that involves differentiation, that involves integration. I'm going to be giving you more information on that, but this video, I just want to use it to teach you guys that are not doing mathematics or that have never done further math before. I want to teach you some basic calculus tricks that you need to know to solve physics problem. So I'll start with basic differentiation. Now, so when you have a function, let's say y equals a function of t. So I'm using t because most of the questions that you'll be given, since it's a motion problem, it will have to deal with time. So the function is a function of time. So t is time. So when they ask you to find, maybe there are questions that will require that you find the derivative of the function. There are questions that will require that you find the integration. So I'm going to teach you all of those things in this video. So let's say, for instance, now you want to find the derivative of a function. That is also known as, so if you're given as y prime, it also means derivative of this function with respect to t. Or if you're given dy dt, it also means the derivative of the function with respect to t. In fact, sometimes you can see it as f prime of t. Now, when you have this particular thing now, so I'm still going to give you a function. There is a general rule for derivative. So let's say this function is of the form a t raised to power n. Note that this y is a function of t. Y is the dependent variable, t is the independent variable. So as you can see in this place, a and n, they are constants. So basically t is the variable that we are dealing with here, and we're going to be differentiating. A is just a number, n is a number. So example of what you can have is, let's say you can have a function s equals, let's say 2t raised to power 3 minus 4t squared plus 5. So as you can see now, I've changed this thing now. This is a function of, this is s as a function of t. So you can see that 2 is a constant, 3 is a constant, 2 is a constant. So all of those numbers, so that's the model that we have here. So generally when you want to differentiate something of this nature, so what you do is that, so the derivative of this function y prime, so y prime equals, the first thing you need to do is that you need to use the power to multiply the coefficient. You need to use the power to multiply the coefficient. So this is n multiplied by a. That's the first thing you need to do. Then the next thing you need to do is, don't forget our t still remains the way it is. So then you remove 1 from the power. So that's n minus 1. So which will give you na, then t raised to power n minus 1. So quickly, if we apply that to this, s equals 2t raised to power 3 minus 4t raised to power 2 plus 5, that implies that we're going to have, so s prime now, so is that we are saying we are looking for s prime, or we are looking for ds dt. So you can see how that it is not every time that it is dy dx. It is based on the dependent variable versus the independent variable. So when you're writing your derivative, it must be the function that is depending on the independent variable. So ds dt in this case. If s equals maybe 2x or whatever, it would have been ds dx. So differentiation is not all the time dy dx. You just have to know your dependent variable and the independent variable. So for this function right here, I'm looking for ds dt. So let's follow it one after the other. So if we use this pattern of what I've taught you now, the power will multiply the coefficient. Then afterwards, you remove 1 from the power. So let's start now. So this is 3 here, which is the power. 3 will multiply 2. What would that give us? That will give us 6. That will give us 6. Then t will still appear. Then you subtract 1 from 3. 3 minus 1, that is 2. So we are done with the first part. Let's move to the second one. The second one has a negative sign here. So we have 2 times 4. That is what? 8. So we have negative 8. T will still come up. Then we have 2 minus 1. 2 minus 1 is 1. So we don't need to put any 1 there. Now you see, one thing about constant is that I want you to know that if you are differentiating constant, it becomes 0. So with this, you are done with the derivative of this. And this is what basic differentiation, this is what it looks like. Now, how can you find this in motion? So here's what happened is that this s if you remember your equation of motion very well, you notice that those equation of motion, S mostly represents displacement. So they can tell you that this is a displacement function. So I'm just going to copy this and I'm going to work with it now. So if this is your displacement function, so let me just put that down here. So if this is a displacement function, as in S is a displacement function, what you can get from here is that you can get velocity function and you can also get acceleration function. In fact, the velocity function, which is v of t as well, is the derivative of the displacement function with respect to time, which is what we have already gotten here already. So just differentiate this, then you put it here. But we can also get the acceleration function. So acceleration function, which is a of t, is actually the derivative of the velocity function with respect to time. So what are we going to do is that this answer that we got here, we're going to differentiate it again. So we have, let's go again, 2 times 6, that's 12. So we have 12 here. Then 2 minus 1, that's 1. So we leave it as 12t. So minus 8t, so we say that there's power of 1 on here. So we have 1 times 8, that gives us negative 8 because of this negative sign. Then we do 1 minus 1, that is 0. So t raised to power 0 is 1. So that leaves us with ordinary 8. So you can see this. Now this is the acceleration function. One thing you should notice is that there's something called higher derivative. Higher derivative is when you are differentiating more than once. So if I don't want to write that acceleration function is dv dt, don't forget that the result I got here is the second derivative of the displacement function. So meaning that acceleration function is also the same thing as the second derivative of the displacement function. So this means that whatever our displacement function is, we'll differentiate it the first time, we'll also differentiate it the second time. So this and v of t, this and dv dt, they are actually the same thing. So that is one of the basic that you need to know. Now, here's now the thing. If they ask you to find maybe distance or displacement, or they ask you to find velocity, or they ask you to find acceleration. And there are two types of acceleration that you know. There is the instantaneous one and there is the average one. So if they ask you to find instantaneous velocity, anything instantaneous, it is different from the actual average of that component. What I mean is that you can be asked to find instantaneous velocity, you can be asked to find instantaneous acceleration, and you can be asked to find average velocity, also be asked to find average acceleration. So how do you differentiate between these two? So if still using the function that we're given, if you're asked to find instantaneous of anything, now another time they will not say that find the instantaneous velocity. They can just say that find the velocity at a given time. Let's say when the time is 3 seconds. They can ask you to do this. They can ask you to find the acceleration when the time is 2 seconds. Now, so whenever you are given questions like this, or they emphatically say that find the instantaneous velocity or acceleration at a given time, what you are going to use is that you're just going to come and plot. So for velocity, you're just going to come and plot this guy. So v of, so what time? Time is 3 seconds. So you plug the 3 in the function. So from the derivative you have gotten, you have this. So you just input 3 in this place, 3 squared minus 8 times 3. So you can use your calculator to solve this. You just do 3 squared, which is 9, then you multiply it with 6, then you subtract this. So also, if you are going to look for the instantaneous acceleration at when time is 2 seconds, that is a of 2. So you're going to have 12 times 2 minus 8. Also, you just multiply this. 2 times 12 is 24. Then you subtract 8 from it. Then you get your result. So don't forget your unit as well. Now, that is for instantaneous. Whenever they ask you to find instantaneous, you look for the function as I've taught you, then you put the value of the time. But sometimes they can ask you to find, let's say, the average. Whenever they are dealing with average anything, the average, let's say average velocity is what they say you should look for now. They will always give you between a time. They can say between the time 1 to 3. They can ask you to find the average acceleration between the time, let's say 2 to 4. Now, what does this mean? So, whenever you are given a range of time, that is an initial time and a final time, in that situation, you're not going to be able to use the instantaneous way. So, for velocity, what you have to do is that you have to go back. Don't forget the formula for velocity. Velocity in your normal motion problem. Velocity is what? Change in displacement over change in time. So what does this mean? That means that change in displacement, what's the final time here is 3. So s of 3 minus s of 1 divided by, what is the final time is 3 minus what's the initial time 1. So I've already explained to you how you can find s of 3. So what do? You just go and input 3 inside this function, so you get your answer. So you put 3 raised to power 3, 3 raised to power 2, you get your answer. You input 1 as well, you get your answer. Then you subtract them and you divide it by 3 minus 1, which is 2. The same thing for the average acceleration as well. So average acceleration, that would be, so don't forget, acceleration is what? Change in velocity over change in time. So this time around, the function you'll be using will be what? V of t. So that will be what? V of the final time there is 4, based on this interval given, minus the initial time is what? Is 2. So you have V of 2. Everything divided by 4 minus 2. So you can see the difference between instantaneous and average now. So if you have any question on this, you can always comment and I will attend to you. Now let's proceed. That is the basic differentiation. Now, there are some, maybe a little bit of complex differentiation where we have what we call a product rule. Sometimes we have what we call a chain rule, and sometimes we have what we call a quotient rule. So let me quickly run through that. I'm not going to be doing a complex form of any of these things. So let me just quickly run through it. Now, let me start with chain rule. So chain rule. Now, what does this thing deal with? This thing basically tells us that if I have a function, so y equals, let's say, f of g of x. So let me continue to use t because we are dealing with motion here. So f of g of t. What does this mean? This implies that whenever you notice an anomaly in a function, such that one function is carrying another function. For example, I could have y equals, let's say, 2t raised to power 4 minus 6t. No, that's a normal thing to have. And I can also have, let's say, y equals, let me call this one y1, let me call this one y2. And I can also have y2 equals, let's say, 6t raised to power 3. Now, when I have these two, you can easily apply the derivative rule that I've given you. If you want to differentiate this y1 with respect to t, you go ahead and do what I've taught you already. And if you want to differentiate this y2 with respect to t, you go ahead with what I've taught you already. But what if I infuse these two together to get a new function? Let's say my displacement function now is 2t raised to power 4 minus 6t, everything raised to power 3. And let's say I'm putting a 6 there. So what you notice is that this t, I've replaced it with an entire function. So that means that there is a function inside another function. So how do you always recognize this? It is by practice. When you practice more, but in your exam, they won't really give you that very advanced problem. So you don't really need to worry that much. So let's go forward. Now, to differentiate something like this is where the chain rule comes in. So what you do is that you look at that innermost function. That innermost function, you assign a letter to it. So you say let maybe u equals 2t to the fourth minus 6t. For everything you are assigning letter to, you must find the derivative. So you find the derivative. This is du dt. So let's go it now. Du dt will be 4 times 2 is 8. Then t, 4 minus 1 is 3. So minus, you know what this one will be? This one will be negative 6 like that, because 1 times 6 is 6. Then So minus 6, let me write that properly. So then 1 minus 1 is 0. So you get familiar with that as time goes on. Now, when you're done with this, what does that leave you with? That means that your original function has become something else. 6. So everything inside here has become u. So we have 6u raised to power 3. Now that you have this now, then don't forget I told you that it's not every time that it is ds dt. This s, as you see it here now, it is now what? It is now a function of u. So you can guess what the derivative will look like. What will the derivative look like? That will be ds d what? du. So this will now be, so let's differentiate that. That will be 3 times 6 is what? 18. Then what is u? U is, then we subtract 1 from the power. So that's u raised to power 3 minus 1, which is 2. So we have this now. Then what does chain rule says? Because I've only assigned one new letter here. So what we are looking for is the s dt originally. That is, from our original function that was given, which is this. What we need is actually the s dt. So let's now see the way chain rule is formed. So the s dt will just be ds. What was the first letter that I assigned? You can see that I assigned du. So ds du multiply by. See, from this du, we continue up here. That will be du. Then from there, we now get to du dt. So let us say, let me quickly like digress a little bit. So let's say we have a function y now. Let's say that function is a function of u, a function of g, then it is a function of t. So let's see how we'll go. So we'll go like this, dy dt. That's what we are looking for eventually, y with respect to t. So you notice that this dy dt, which function are we going to get to first here? It is u. So we have dy du multiply by. So from this du, we go again, du. What's the next function? G. dg dot, then we'll go from this dg again, dg dt. So when you look at this very well, you realize that the u can cancel out, the g can cancel out, and we'll still be left with dy dt. But don't forget, each of these are components. Now, for your physics post UTME, you won't get it as complex as this. I'm just trying to be a little bit detailed, so don't worry about too much about this. So let's go back to our calculation. So from our calculation, we already have ds du. What is ds du from what we calculated? Ds du is 18u squared. So that's 18u squared multiplied by, what is du dt? Du dt is 8t raised to power 3 minus 6. So this is what we need to, now what we need to do to finish this whole thing is that we need to substitute u back, because this function has to be purely in form of t. So what was our u initially? U is this. So I will write 2t raised to power 4 minus 6t. Don't forget, I'm just replacing u, so it will still have a power of 2. Then I have 8t raised to power 3 minus 6. So I'm just trying to make this question as complex as possible. In your post-UTME, it's not going to be this complex, so don't worry. And with more practice, you can easily get this thing. So let's proceed now. So with this, we have this solution. That is the chain rule. Now, I'm going to be doing product rule and quotient rule. So I'm not going to be too detailed about it, because I've already shown you what it could be like. So for product rule, so what happened is that y is a function of u times v, and the rule is that dy dt is, so you first of all pick u, then you have dv dt plus v, then you have du dt. So an example is, let's say you have y equals, let's say 2t squared into bracket t plus 4. So instead of opening the bracket, you can just label each of them. So let your u be 2t squared. That implies that the u dt will be 4t. And let your v be the other side that is multiplying it, which is t plus 4. So when you differentiate the v dt, what you will get is 1. By now, you should be used to that already, so you can practice as much as you like. So the derivative of y with respect to t, so that is your dy dt, is then going to be u dv dt. So what's your u? U is 2t raised to power 2 multiplied by what is dv dt? That is 1, plus what is the next in v, which is t plus 4, then multiplied by the u dt. What's the u dt? That's 4t. Then with this, you can, finish it up. So one that look like it is our quotient rule. So for quotient rule, I'm not going to do any example on this one. I'm just going to give you the rule. So it is when y is, let's say, u over v. So a function u over v divided by v over t. Then the quotient rule, which is dy dt, is given as v multiplied by the u dt minus u multiplied by the v dt divided by v squared. So this is like for differentiation. In my next video, I'm going to be talking about integration, just the basic thing that you will need to know for your post-UTME only. Don't forget, if you're a mathematics student, if you're taking mathematics, you might need to know a little bit advanced calculus more than this. But for your post-UTME, physics generally, this is going to be sufficient for you. For differentiation, anything that will involve differentiation. So don't forget, this is just a summary video. You need to practice as well. And then if you're on my WhatsApp page, you can always like reach out and I will put you through on 1 or 2 things. Don't forget to subscribe and follow. I'll see you in the next one.